Welcome. Today we'll solve an implicit differentiation problem. Let's find dy dx for the equation sign of x plus cosine of y equals sine of x times cosine of y. To find dy dx using implicit differentiation, we need to differentiate both sides of the equation with respect to x. Remember, when we differentiate terms containing y, we need to multiply by dy dx due to the chain rule. Let's differentiate the left side first. The derivative of sine of x is cosine of x. For cosine of y, we get negative sine of y times dy dx. Now for the right side, we use the product rule, since we have sine of x times cosine of y. The derivative is cosine of x times cosine of y plus sine of x times negative sine of y times dy dx. Let's combine these into one equation. Cosine of x minus sine of y dy dx equals cosine of x cosine of y minus sine of x sine of y dy dx. Now let's solve for dy dx. First, let's get all terms with dy dx on the left side and all other terms on the right side. Negative sine of y dy dx plus sine of x sine of y dy dx equals cosine of x cosine of y minus cosine of x. Let's factor out dy dx from the left side. We get sine of y times sine of x minus 1 times dy dx equals cosine of x times cosine of y minus 1. Finally, we can solve for dy dx by dividing both sides by sine of y times sine of x minus 1. Therefore, dy dx equals cosine of x times cosine of y minus 1 divided by sine of y times sine of x minus 1. And there we have it. We've found dy dx using implicit differentiation. Remember the key steps. Differentiate both sides with respect to x, use the chain rule for terms with y, collect terms, and solve for dy dx. Thanks for watching.